Example 46. Use the table below. Find the probability of a single randomly selected subject having a false positive or false negative exam result. So when I read this problem, it's clearly a probability problem. There's also clear indication that just one single subject is being selected, right? Only one subject, so it's a probability problem where they're selecting only one item or one thing or one person. And then we have the word or present. So it looks like it's addition rule of probability because it's the probability of a single randomly selected subject having this trait or this trait. So it's pretty clear it's addition rule. Now based on that, we're going to write a statement that includes the things they're asking about. So it's a probability of a false positive, right? Or a false negative. So that's what we're trying to find here. Probability of a false positive or false negative exam result. If we write it out using the rule formally, the formal rule says that we should do probability of false positive first, plus the word or becomes an addition sign, the probability of a false negative, and then we should subtract off here the probability that a person has a single test that's both these things, right? That would be false positive and false negative. So let me ask you, does that make sense to you? Could you have a single test result that's both a false positive and a false negative? First of all, it's just one test, right? One test that we're taking, one pregnancy test that we're looking at for one subject. And so that test should only have one conclusion. It should either say the person is pregnant or they're not pregnant, right? That's the first issue. So it's unlikely you would get a test that says, hey, you're pregnant, and also, hey, you're not pregnant at the same time, right? That doesn't seem reasonable. But even if a test could malfunction that way, where it gives both results, it certainly couldn't be wrong both times, right? I mean, imagine if you had a pregnancy test in your hand that said, hey, you're pregnant, or hey, you're not pregnant. It says both things. It says, hey, you're pregnant and you're not pregnant. They can't both be wrong, right? Because if you're pregnant, then the statement you're pregnant is correct. And so it can't be a false positive in that case. And if you're not pregnant, the statement, hey, you're not pregnant, has to be correct, right? So the bottom line is that they can't both be false. That's impossible because everyone on the planet, even men, right, they're either pregnant or they're not. Of course, in men's case, they're always not pregnant. But the idea is that for every person, you can't be both false positive and false negative for pregnancy, right? It's got to be one or the other, right? Either you're pregnant or you're not, and as a result, they can't both be false. So either way, regardless of how you see that this doesn't exist, you can say that that doesn't exist. It would never happen. These two groups are mutually exclusive. You can't belong to both at the same time. Not with one test anyways, right? So at that point, what we're going to do then is to look at these two fractions that are left over, and the rest is pretty simple from here. This is going to be two basic probability fractions added together. And remember, that's always going to be number of over total. Number of over total, right? So number of what? Well, number of false positive test results, right? False positive test results. And here will be the number of false negative test results, right? Okay, so let's go ahead and fill in the numbers now that we know exactly what we're looking to put in these fractions. Well, the number of false positives can be found basically in the positive column that doesn't seem to be correct, right? We should have a column that's positive that isn't correct. And what I mean by that is, okay, a false positive is first and foremost a positive test result, but it's a test result that's an error. So which one of these numbers here, either 80 or 3, are most likely to be a mistake? Well, first of all, just by its sheer size, probably the 3 is the mistake because it should happen. Mistakes should happen less often than correct conclusions, right? But either way, if we look here, it says the subject is not pregnant. So this is the actual reality, the truth of the matter, and this is what the pregnancy test indicated. So we had volunteers, some who were pregnant, some who weren't, and they went and took this urine-based pregnancy test to test its accuracy. And of course, they would have confirmed the person was pregnant, maybe using, a sonogram or something else that's definitive, a blood test, whatever. But either way, they know that these rows are true. So when it says subject is not pregnant, people in this row, all the 14 people here, they're not pregnant. And yet, 3 of them were told that they were pregnant according to this test. So that means these are false positives. There are 3 false positives then out of the grand total of 99 subjects. Now, number of false negatives. Well, false negatives are negative test results that shouldn't have happened. So these subjects in the top row, they're all pregnant, but 5 of them were told by the test that they're not pregnant. Pregnancy wasn't indicated for those 5 women, so that would be 5 out of 99 in that case. And so to put it all together, we end up with 8 out of 99. That's a little more than 8%. If you want to work it out to get the precise decimal form, it's 8 divided by 99, and it'll give you basically 0.081, let's say. Okay, so there it is. That's basically our answer. So about 8.1% of the women in the study received some kind of an error on the test, either a false positive or a false negative test result.